today we are built entirely on bitmaps and like key value stores. And what we're the work that we're doing is um, we're going to be able to store essentially like columnar um, numeric values in a columnar data format alongside the bitmaps. And that's currently implemented with Apache Arrow. So what I was going to do is just kind of ingest some like toy data sets and then walk through a Jupyter notebook, kind of uh, highlighting some different things we can do, some new things we can do with that additional like data store or data format. Um, Certainly not like exhaustive by any means. It's kind of um, just some of the things we can do, and I think we're um, still at the stage where we're kind of like cleaning this up
I
as
can't
far
hear you
as
because
like
I'm
building interfaces around things, but
recording.
um, and really like exploring all the things we can do with it. Yeah, so if are there any questions before I jump into the demo?
Uh, Jacob, do you want to make mention of kind of what motivated this? Like, what are we trying to be able to do with this format?
Yeah, yeah. So I think the motivation is to really like um, build more functionality into FeatureBase. So I think our goal is to move towards like a more general purpose analytics database, and I think storing data in a new format will allow us to do um, different things or more things um, more effectively with FeatureBase. So um, I think the initial motivation was to be able to do like compute the similarity between two records. Um, and that's something I'll walk through like how we can do that with the existing or like the new functionality as it is today. Yeah, what I have is just like two data sets, and um, one is like just people and like um, I think like age, weight, height of people. Um, and so that will be sort of right now it's ingested by two different processes basically. So one to write to bitmaps and then another to write towards like arrow. So that's the CSV file to get the data into the we're calling it like a data frame, and then here is the file to get the data into FeatureBase, like the traditional data store. And so you can see I just have name, age, height, weight, and then I'm just pulling the numeric values and storing those alongside of in a columnar format alongside of the bitmaps. So um, can go ahead just that. So that was quick, but this is just the command to get to write a CSV file to FeatureBase. So I just pointing out the index, the primary key, and then pointing it to a file. And similarly, for the data frame, we have another binary and pretty similar. So it's just a binary and then pointing it to a file and the index that you want to write to. Right now, for both of those files, the schema is defined by the header. So you'll see like age, I'm bringing it as an int, height, I'm bringing it as a float, same with weight. Um, but yeah, so we can see we've got that table created. And if we do just do like a select all from people, this is just pulling back what's in like binary or the bitmaps right now. So there's no, it's not actually pulling anything from the UI, at least from the data frame. And then Okay, so that's going to be for like a similarity calculation in FeatureBase, and then I'm going to load um, one more data set to kind of highlight another new thing that we can do with the new data format, and that is the sales data set. So again, two files, one for each ingest, but it's just um, like an event ID, a price, and a quantity. So pretty simple. So that's the command to read the data into the bitmaps, and then there's for the data frame. So again, we can look at the UI. We can see what data is currently stored in like the traditional feature base um, in the bitmaps. Settings. Okay, yeah, and I guess we've got a product as well. So that's just in feature base. So we're just pulling the numeric values into the data frame. Okay. Any questions there? Already. Um, so I'll jump to the Jupyter notebook, and this is where we'll start querying the data. Is that text okay for you guys?
Is it possible to zoom a tiny bit, Jacob?
Yeah.
Awesome. Thank
Yeah.
you.
Yeah. Okay. Okay, so the first couple queries here are just how we access the data that's currently stored um, like in memory as Apache Arrow. Um, and so here's an example of extracting just a single row. And so what this query is doing is it's filtering the records for only people whose name is Amy, and then it's pulling these features from the data. And so I couldn't do something like name here because I didn't pull that data into the data frame, but I'm just pulling the numeric values. The first one's an ID, and so this is like this gives us the ability to tie records in the data frame to records in FeatureBase. But then you can see then it's reversed here, but the age, uh, uh, weight, and height. So that's that extracting a row, and then we can also extract a column. And I will say that this is like not new functionality, but just kind of showing how you can access the data, um, the new data format. So here's an example of pulling a full column. So pulling all the weights for all the records. So this is just saying all the records, grab the weights, and essentially don't do like any transformation um, on what was returned. So you can see these are um, all the weights. Okay, and then we can kind of combine those, and we can pull all of the data um, from what's being stored in the data frame. And so that's again, we want all the records in these like columns or fields or features. I mean, that's what we get in an output here. Okay, assuming there's no questions there, I'll go into like essentially one of the things that you can do with this data format that we weren't able to do before. And so these first two cells are things that we can do in FeatureBase. So this is like a traditional like SQL query. What we're doing is just summing the price over all the records. And I guess this might be a little confusing, but just as like a refresher, this is what the sales table looks like. So we've got price, product, quantity. So we're summing price over all the records in the sales index. So that's something we can do today. We can sum over the bitmaps, and then we can also sum like an int. So this is like a decimal. We can sum an int. But what we can't do is like do something like give me the product of quantity and price and give me the sum of that, right? So that multiplication between columns or like fields. And so that's what I'll kind of walk through the steps of doing that then against a new data format. So this query is saying, give me all the records, give me price and quantity, and then we can like kind of store those in variables. And then this first query just displays those. So this is just saying like, give me A and B. And so you can see this is the quantities and this is the price. And then what we can do, so basically the same query, but now we can multiply those two together. And so now we get like price times quantity. And then finally we can then sum that. So, and so that's new functionality. And then here's an example of like what I think makes this powerful is we can use then all the strengths of the bitmaps to like segment our data. For example, like give me the sum for only this product, and then and then compute this like price times quantity summation. So so that was the first example. I've got one more, but any comments, questions, thoughts?
Jacob, in the chat, Sarah just asked, is it fair to say that this enables floating point support?
Yeah. So one of the like there's two data types that we've got in the data frame. One is an int and then one is a float. So yeah.
Awesome.
Cool. Okay, so then
Sorry, I thought of one more question. Are there any, like, obviously everything here seems to be running pretty fast, but it's also a pretty small data set.
yeah.
But in terms of performance capabilities, like, are we still super fast, or are there any hits to it there?
Yeah, I think I think we're kind of at a stage in development where we haven't really worked necessarily on optimization yet. So that's a question that's unanswered. I think, and I don't know if Todd's on. Todd's done, I think, the majority of the development on this, so he can probably weigh in with his thoughts like better than I could. But yeah, I think it's mainly unanswered. But like one thing, like this, like segmentation of records is it's just operating on what exists today, so that is still going to be fast. And I think, you know, the more that we segment our data before we operate on it, the more that we're utilizing the strengths that we have today. So that would still be fast and like competitive. But as far as like you said, if we're computing the sum of a column over billions of records, I'm not sure we've answered that yet.
Okay.
Sorry, just to kind of continue on I think Laura's line of thinking. If you were doing something like this today, would you have to segment your data in FeatureBase and then pull it into some other tool to do those analytics on it, or am I missing something?
Yeah. For example, like for this example above, like there's things that we can't currently do like on the FeatureBase server. So like I think like the goal is to push as much computation to like the database server as possible. And like like today, if we wanted to compute like the product of two columns and then like sum it, you'd have to segment the records, and then you'd have to pull the two columns back, and then client side, you'd have to multiply them. So, did that answer your question?
Yeah, absolutely. Thank you.
Cool. Cool. Okay. So the next example is again, or is on the people's table. So I'll just show that again. And this is an example of computing like the similarity between two records, which is something we can't do with FeatureBase today. But yeah, so we've got like each record is a person and they've got an age, height, and weight. And what we want to do is compute like the Euclidean distance between people. So like the closer they are, the more similar they are. And we'll be doing that just off of the numeric fields. So I kind of broke that out into steps. There's multiple ways to do this. We use, so currently we're using a Go library called Ivy to operate on Apache Arrow. And if Todd's on, correct me if any of that's incorrect. But so from like a functionality standpoint, we can really do like anything that Ivy supports, we can do. So there's multiple ways to compute the similarity between like vectors or records. But this is one way, and it kind of highlights some new capabilities. So I broke it out into steps just to like see what was going on. So yeah, I'll walk through that. So this query, the first query is, so we're segmenting our records in FeatureBase. So we're saying, give me the record for Amy and John. And then we're going to pull their height, weight, and age. And that's what we're going to do kind of the computation on. So I guess the first thing we could do is like pull both of those back. So you can see like this is John, this is Amy. And then to compute the similarity or the Euclidean distance between them, we'll take the difference, square them, sum that, and then take the square root. So the first step is taking the difference. So that's what we can do here. And then the next step is squaring those differences. And that's, you can see that really just changing this like final step of the query. So we're changing like how we're operating on the arrow data. So take the difference, then square it, which, like products, multiplication, like we saw, isn't something we can do today. So this is new functionality. And then we want to sum those. And that's what this like plus forward slash is doing. And finally, we want to take the square root. So this would be the Euclidean distance between Amy and John. So like how similar are they? And then you could compute that with Amy against everyone in the index or in the table, and you can kind of figure out like who is she most similar to using this method. So, and that's all I had.
That's an intro. Thank you for doing this demo. It's awesome. One question / comment I just wanted to make and make sure you agree with me and everybody sort of understands this. The data frame is essentially inserting a traditional database-like field into FeatureBase. So you don't get the compression and speed you get by doing the more traditional bitmap representation. So it's like we've loaded more traditional database inside of FeatureBase to handle a few fields that might require functionality that FeatureBase doesn't yet. Okay? So it's going to be much bigger. You're not going to get this compression. And it could be, especially for the large data sets, much slower than doing a bitwise operation on the bitmap portion of the database. Are those fair assumptions?
Yeah, I would agree with that.
So essentially, we are like any other database when we're using the data frame.
Yeah, similar to like I think like ClickHouse uses Apache Arrow, I believe. So yeah, similar to them in that case.
So we really need to leverage FeatureBase as much as possible, or the more traditional bitwise columns as much as possible, and limit the usage of the data frame except for the parts that FeatureBase can't do. And I know this is one of many steps that Todd and Ledger and Pat are thinking about, because there will be ultimate ways. We've found this new bit slice floating point technique that's very much like bit slice indexing, that will allow us to actually do, floating point natively using bitwise representation, so we can get the speed, so we can get the compression. But for now, this is a great step forward, because otherwise you have to load an outside database to manage operations like these.